It says, determine the empirical formula for a compound that contains carbon, hydrogen, and oxygen. It contains 52.14% carbon and 34.73% oxygen by mass. So, as we talked about in the previous question, number 8, the empirical formula is the simplest ratio of moles. But in this case, we don't have moles, we have percentages. So the first thing we need to do is convert these percentages to grams. The easiest way to do that is to simply assume you have 100 grams of the sample. So if I have 100 grams of the sample, I have 52.14 grams of carbon. And I would have 34.73 grams of oxygen. But I'm also told that this sample has hydrogen. So how am I going to find out how much hydrogen there is? Well, if I have 100 grams of a sample and 52.14 grams are carbon and 34.73 grams are oxygen, the rest of the 100 grams has to be hydrogen. Specifically, what I would want to do is I would want to take the 100 minus this and then minus this. And when I do that, I would find that there were 13.13 grams of hydrogen. Now, in each of these cases, I don't want the simplest ratio of grams, I want the simplest ratio of moles. So I have to convert these all to moles using the molar mass from the periodic table. So for carbon, I put 12.01 grams of carbon on the bottom, because that's what it says is the molar mass on the periodic table, and I put 1 mole of carbon on the top. For oxygen, I put the molar mass of oxygen, which is 16.00 grams of oxygen on the bottom, and 1 mole of oxygen on the top. And for hydrogen, I put 1.01 grams of hydrogen on the bottom, and 1 mole on the top. Now I can convert all of these to moles. And I find that there are 4.34 moles of carbon. I find that there are 2.15 moles of oxygen, and I find that there are 13 moles of hydrogen. Now, this is still not an empirical formula. This is just the number of moles, essentially in 100 grams of this compound. To find the empirical formula, I need the simplest ratio of these moles, and I need a whole number ratio. Because I need a whole number ratio, said another way, I don't want a fraction, I want to divide these all by the smallest number. If I divide them all by the smallest number, that one will be 1, and all the rest will be greater than 1, so I won't get a fraction. In this case, the smallest number is 2.15. So I want to take this one and divide by 2.15, and that comes out to be 1. I want to also divide this by 2.15, and that comes out to be approximately 2. Remember, it has to be a whole number. You can't have a fraction of an atom. And I take the hydrogen and I divide by 2.15, and it comes out to be approximately 6. So now I can find my empirical formula. My empirical formula is I have I have 2 carbons for every 6 hydrogens and 1 oxygen. All right, the nomenclature is that we write carbon, hydrogen, then oxygen, and you can see all the answers are that way. Even though we solve them as carbon, oxygen, and hydrogen, this is the traditional way to write this. So if we look up here and we find our correct answer is choice letter